In this video, I will talk about the Parser module. Although in the textbook there are two separate Parser and code modules, the Parser analyzes each assembly instruction and the code translates the instruction into binary instructions. In my design, I put the code as a part of the Parser. Let's go to the code. Here is a Parser instance. Hold the control button and click here to go to the Parser class. The dependent library are very similar to the symbol table class. Because we are using the symbols already stored in the symbol table, we include the symbol table in our Parser class. Because the symbol table is firstly instantiated in the main file, in the Parser header file, we specify it is an external object. Here is the interface for the Parser class. There are three private map type dictionaries, which implements all those three tables. The computation dictionary, which matches each assembly code to its corresponding binary instructions, and also the destination and the jump dictionary. For A type instruction, the prefix is always 0. Look here, 0, 0, and 0. However, for C type instruction, the prefix is always triple ones. Although the second and the third ones doesn't matter if it's 1 or 0. In the example assembler, C instruction always translated into triple one with a prefix. I follow the same style. So this function comp entry, which takes a string type key, which is those human readable instructions, and the value is a corresponding binary sequence. It is this function is very simple. Let's go to the definition of this function. Seems doesn't work. Let's go to here. Here it is a comp entry. It takes a key value and key and a value, make it a pair. Remember that inside map standard template library map, each entry is a pair of two data elements. I specify they are both strings. Both human readable instruction and binary instruction are strings. And I insert it to the computation dictionary. Similarly, I do the same thing for destination and the jump terms. Once added those in dictionary terms, we need a function to look it up from the dictionary. The lookup function is here. You put a human readable instruction like this, not D into this function. It will search. It will try to find the corresponding term. If it is equals the end of the table and still not found, we can see we can go to this default form and output the default value. Here, instead of output 0 as a default value, we can also throw an exception to tell the user your code may contain error. Actually, we should do that. Otherwise, the corresponding term is found in the dictionary. It just dereference the corresponding term and return the second column, which is a binary sequence. Similar thing happens for lookup destination dictionary and jump dictionary. Here we come to the parse instruct function and parse instruction function. Let's first talk about the public parse instruction function, because this is the root here. Whenever we read a new instruction, it is passed as a parameter to this function. We will first check if this function is started with add character or not. Here we use a find function from the string class. You can see it's in the string class. And here's a nobs. Nobs means not found in the string. If it's not equals to the nob, it means there is in this string it contains a add character. So we do this. We do your substring skip the number 0. Number 0 is the very beginning of the string, and then go to the very end. Keep anything between. Remove the add character to the end of the line, which is the remainder of this instruction except to the add character. Then we put it into a parse instruction function to do the rest parse tree. Let's go to this function. Yeah, here it is. Now we are at this step. The instruction is passed from here after removing the add character. Here we first check if this instruction contains any of the number. There are template to compare against. 0 to 9, that's any number. If it equals nobs, means not found any number in this string. Just return. We use a function stoi, which stands for string to integer. Put this string in here, and we cast it to a 15-bit integer number, because because leading 1 is used to indicate it's an A instruction. The rest are 15 bits valid integer numbers. And then we convert this whole stuff back to string and add to the prefix. Remember that? What is a prefix for the A instruction? Is this leading 0. It is very convenient in C++ string. We just use add to concatenate this 0 to the converted binary value. Let's consider if this instruction contains a number, what will happen? I will do this. If find any number at a smaller index than non-number part, it means number first, then letter. It is an invalid case. So I throw a runtime arrow to indicate there's it is an invalid input, invalid A instruction. Otherwise, letter first and then number. I do this. I use a lookup symbol function from the symbol table class. I initiated this my symbol table in the main.cpp, my assembler.cpp, which contains the main function. Let's go back to here. Look up this and get a return address value. Do the same thing as there. Set. Convert the corresponding address into 15 bits binary string, which is this part. Look up and convert to the binary value. This also handles a new variable, because in this lookup symbol it will firstly open up this symbol table. The lookup will try to first add the new variable into the symbol table. If it is already exists, just return the just skip the add process and return the corresponding address in the random access memory. Now let's continue this. After that, append prefix 0 and return as a binary sequence. Okay, that's our pass A instruction. What happens if the data instruction is a C instruction? It goes here without a leading at character. It will go this way. Go to the pass tree will go to this branch. Okay, pass C instruction. The instruction will be split into 3 parts with a delimiter, equal, and a semicolon. We will find the position of the equal sign in the string. Also find the position of a semicolon. If this equal sign is not found in, it is possible. In some C instruction, there's no equal sign like this. 0 semicolon jump. So this will happen. When this is true, it will go to here. It is null. So the instruction dist destination is null. Also, if we have this semicolon not found, the jump will be null. Otherwise, it will chop this instruction into three pieces. Split it into three substrings. We do this substring from 0 to the equal sign. From 0 is the very beginning to the equal sign is this part. And from the equal sign plus 1 to the column sign minus 1. Let's see, where is the column sign? Column sign is this. The equal sign is not found, so it's 0, and to semicolon minus 1 is just this part. 0 is a computation string. And here is a position of a semicolon to the set minus 1, which is a very end. It's this part, semicolon plus 1 to the very end, just this part. Okay, now I put those three substrings into a lookup function. Let's go to this lookup function. Let's imagine it's the computation is d minus 1. Let's imagine that's this one. So it will first try to find it in the dictionary. The dictionary is actually established in the constructor of this parse class. Here we have make three clean dictionaries and add all of those entries corresponding to those three tables. There are a few things to emphasize. Is this d plus 1 is actually commutative. Commutative means you can swap the order of d plus 1 to 1 plus d. They are equivalent. So I will have this 1 plus d and d plus 1, two terms. Okay, go back to where we were. Look up here. If the computation is not found, just output 0 as a default. Otherwise, look up that dictionary and find what is corresponding to this d plus 1. It is 0. Of course, there's a bit. So it is 0 for the a bit, and then 0, 1, 1, 1, 1, 1. Return this. Return this as a binary sequence string back to the parse C instruction. Now this is looked up, and combine all those three. Also prepend with this prefix C, which is defined here. Prefix C is 1, 1. Now we have a complete C instruction. C instruction expressed in binary form and return to parse instructor here, and then it immediately return this function, return to where this is called parse instruction. Actually it is called as the third part. Second parse instruction. Okay, that's it. My video talk about the parser. I will cover the last part for the assembler in my next video. Thank you.